Hi there folks, and welcome to this episode of Michael's 3D World. As promised, we're going to draw an outboard motor part today in Fusion 360. What I have here is a water intake. You can see both of these have holes in them. This one has a big chunk missing out of it, it's broken. These go in the lower part of the gearbox and go together on each side and are sandwiched, and then allow water to come into the lower unit for the water pump to pump water up to the power head. Now, for those of you that are in the 3D printing world and don't know anything about outboards, that information was completely useless to you. But I've been promising my folks that I'm going to be doing outboard motor parts, designing them, reverse engineering them, and printing them. So today we're going to jump into some Fusion 360. This is not, and I repeat, this is not a lesson in how to draw in Fusion 360. Those are coming. I'm putting together a little tutorial on how to draw in Fusion, a beginner's guide, if you will, to get you started off on the right foot, to learn, so it makes it easier for you to learn watching what I do, and then you can take that information and leapfrog ahead and do much greater things than I'm doing in these lessons. So without further ado, let's sit down and get busy drawing in Fusion 360. I'm going to start off with how to start drawing a file here. I'm going to show you how I save it. I'm going to show you the technique for drawing this particular part, what I use to draw it, and my particular end result, what it's going to look like. And let's get going. One of the first things you're going to want to do when you're going to reverse engineer or draw something up is get yourself a piece of scratch pad paper and do like I did here. Just sketch up what you want, some of the critical features, dimensions, things that need to be a certain size, a certain way. Sketch it down on a piece of paper because it'll make it quicker. When you go to draw it up, you don't have to sit there and take a measurement, make a drawing, take a measurement, make a solid, extrude, and different things that we're going to get into. It's easier if you have it kind of laid out in front of you what you're planning on doing, because some of your design intent is important. How do you get to the finished product also starts with how do you begin it. If, say for instance, if you want something, everything centered around the center of your object versus your object being off to one side, there's different origins and different things. We'll get into that later on. But this lesson is just, this isn't a lesson. Almost got myself. This is just to show you how I'm going to draw this particular project. I'm going to save it off. I'm going to convert it to an STL. I'm going to export it to my slicing software. We're going to slice it, and then we're going to print it. I'm going to take you start to finish through the whole process. With that being said, let's jump on the computer and show you what we're going to do. All right, let's get started here. We've opened up Fusion 360. This is our drawing platform I have here. I'm going to pick a view that I want to draw from. First thing we're going to do is go up here and we're going to create a sketch. We're going to click on sketch, and we're going to go ahead and select here because I want to look at the top view there. You see up here, it shows you that you're in the top view. And we're in the drawing mode to draw a sketch now. Now, you can draw lines, you can draw rectangles, circles, and whatnot. We'll get into that later on. Right now, I want to draw a rectangle with the center point of the rectangle in the center of my origin here. And right now, as soon as I click on there and stretch it, as you can see, it's giving me, it's asking for a dimension. How tall do I want this? And I want it 42.8. Then I hit my tab button, and it goes over to the length of it. And I want the length of it to be 73.8 millimeters. And this is the first thing I'm drawing. So now we're going to put a fillet in here. I'm going to click that line up here. You saw I up here and clicked fillet. And I want this to be, what radius did I put on that? Oh, there you go, 7 millimeter radius, be a 14 millimeter diameter. Oops, so I need to put 7. Sorry. I'm going to do this in real time so you guys get the real feel for what is going on. I'm going to do another fillet here. Same thing. Oops. My clicks will not be perfect, folks. Come on. I'm going to show you the real deal here. Another 7 millimeter. There's probably a way that this will stay active till I'm completed with that, but that's okay. So I'm doing a click again. And 7. So that's the basic shape of my water intake right there. Now what I want to do is go up here and hit finish sketch. It's going to go into this mode. I'm going to extrude a solid from it. Now it's going to ask me, how thick do I want it? Do I want this to come up or come down? I want it to go down. And this is supposed to be I had it written down here, I thought. 5mm thick. Yes. So I'm going to put a -5. And now we have a solid. So that's the basis of our drawing. Now I'm going to do another sketch. We're going to go back here and click right here. I'm going to click this surface. I'm going to sketch on this surface now. I'm going to do another rectangle. And I'm going to do the same thing. This makes it easy. Whoops. Didn't click the right area. I hit escape. I go back. Click right here. Now it's asking me for my dimensions again. Now this one's going to be 32mm high. And it's going to be 63.6 long. And then yet again, I'm going to do another fillet here. I want to fill it from there to there. Now, because I'm going to have some raised bosses on here that are 11.5mm in diameter, the corner fillets are going to match the same thing. So we can actually do this. This is kind of cool. What you can do, you can do 11.5. You can put the divided by 2, and it automatically put in your 5.75 radius. Isn't that slick? You may have already known that. So here again, we're going to do 5.75. We'll do it again. 5.75. Oops, forgot to click that. I want to do this in real time just so you guys get an idea of how long it might take you to draw something. And then I'm done with that sketch, for instance, and now I'm going to go finish sketch. It's going to drop back into this mode. I'm going to select this surface right here. I'm going to extrude it. Now this is 0.67 tall. It's a little raised area that it has on the part. And as you can see now, we roll this around. You can see the shape we got here. Now I'm going to create another sketch on top of this. So I'm going to select that surface again, and I'm going to create some circle points, some circles with a diameter. Now what's cool about this is you can highlight across here. It'll pick your circle. Right there's the center of that particular radius. It picked it up for me. And now these are 11.5 in diameter. So we got one there. There we go. 11.5. And as you can see, what I'm doing is I'm left clicking on that circle, dragging to get the box to show up like that, typing in 11.5 with my numbers pad. Hey, if you mess up, you can double click on it, 11.5, and there we go. See? When I make mistakes, everybody gets to learn, right? Then I want to extrude this now. So I'm going to finish sketch there. Now I'm going to select this, and you hold the shift key down. That one, that one. Oops, come on. There you go, highlight. There we go. Now I want to extrude these. And how tall did I have these? These are 12.36 tall. There we go. Hit OK. As you can see, we've already got a generous portion of our design created. Just that quick. Just that quick. Now, these have holes through partway through some of it and all the way through on the other. So what I'm going to do, there's another feature I want to do right down here first. That kind of gets me orientated as to what holes have the big holes versus the little holes. And so I'm going to go ahead and do another sketch. We're going to come back down here to this surface. And then I'm going to draw a rectangle. I'm just doing a 2-point rectangle, and the size of my rectangle here is very small. It's 3.58 by 6.35. Pretty cool. Now, I want to get this aligned so it's centered. One quick way to get this back centered up, since you know this is 6.35, we can hit this dimension, sketch dimension, and we can sketch from, let's just say here to here. And we can say that it's 6.35 divided by 2. That's 3.427. Does that seem right? Actually, that's supposed to be 3.17. 3.175. There. Now it's where I want it. Apparently that divide by didn't work there. Maybe it would. Maybe I did it wrong. Anything's possible. All right, now we want to raise that surface. So we're going to finish that sketch. And I'm going to roll this around so we can kind of see what it's going to do here. I'm going to extrude that. We're going to come up. That is 0.67 tall. Actually, that's supposed to be taller. Oh, it's 2.32 tall. See, I did that wrong. Good. I get to show you how to fix it. Go back over here, edit feature. That's the last thing you did. And we'll type in 2.32. Now it's like it needs to be. Real life drama here happening, folks, live and in person. Okay, now that we got that feature in, we're getting really close to being done. I'm going to roll this around a little bit here. Okay, now I want to draw. I've got it on this surface here and this one here. There is a 6.15 hole that is all the way through the part. So what I'm going to do here is I'm going to sketch again on this surface here. We'll do a circle. And see how it picks that center? I'm going to do a 6.15. This is a through hole for a screw. And I'm going to do another one over here. Doesn't like that. There should be a way I can do that, but I'm not sure. This is me learning still, guys. So what I'm going to do is I'm going to go ahead and finish this sketch here. And I'm going to extrude that. And the distance here is through all. We're going to do a cut. And what the heck's going on here? Why isn't it doing it? There. We just drug it down. As you can see, we got a hole through there now. We'll do the same thing over here. That was a 6.15. Obviously, there's might be faster, better ways. I'm just showing you guys how I'm getting to the finish line here. We'll finish that sketch. We're going to extrude. We're going to pick that surface. It all has to do with the order in which you pick it, too. So we're going to do a cut. And then I'm going to drag that down. I think you can actually, watch this, you can actually select that bottom surface, too, if you wanted. So it automatically cuts it down to there, which is minus 18.3. Hit OK. See, we got our hole. There's more than one way to do everything here. It's whatever you get used to in your practice. Now we're going to take this, do another hole here. And this one's not a through hole. This one was just, we're going to go circle point diameter there. Or center point diameter. And these are 3.4 in diameter. And hit enter. And then we're going to do that. And it needs to be a negative. We'll just go negative 10. And that'll work. Hit OK. I want to do this again over here. Negative. Oops, not negative. This is a 3.4. We're going to finish sketch. Negative 10 again. There we go. We got their holes in the part. What do you think of that? Now I'm going to put a little chamfer around this hole because this has a self-tapping threaded hole or screw that goes in here. So I'm going to help it out by putting a little corner break or chamfer on there. So we're going to put a chamfer on, oops, on that edge. Let me do that again. chamfer there and there. And this can be equidistant, so this is just going to be nice thing. You can type in 2 millimeter. That looks gigantic. We'll type in 1 millimeter. That looks better. Now we got a nice little 1 millimeter chamfer on there. You hit OK. Your chamfer's in place. Now on this side, these have got a flathead screw that goes in them. So we're going to do the same thing. We're going to do a chamfer, but we're going to do a chamfer with an angle. So this is going to be a diameter. Let's just call it 3 millimeter. And we want to do, this is equidistance. We want to do distance angle. I want to do a 41 degree angle because these are normally like an 82 degree countersink. So we'll take half that. And that way we'll have a hole big enough, or the right size. Let's do, I think, did I do 3 or 3.5? I think I might have done a 3.5 before. Yeah, 3.5 was the number. Hit OK. Now you can see we've got everything except places for the water to come through. So we're going to do that next. And now you're going to see why I picked the origin to do my sketching, because it's going to make it easier for doing my next step. So I'm going to do a sketch here again. We're going to pick this surface. Now I'm going to do a rectangle with the center point rectangle here again. And this one I want it to be 2 millimeters, or this is 28 millimeters tall by 2 millimeters wide. Not 22, 2. Just like that. Now this is going to be the slick trick here, folks. We're going to finish that sketch. I'm going to go ahead and roll this around a little bit more so you can see it happen. We're going to extrude that. We're going to go just do a negative 6. I think you'll get through it. Negative 6. Let's hit OK. Now what we got one water slot through here. Oops. Roll this around. See, that went clear through. Got one slot through there. Now the cool part is I want to create more of these, right? And so what I want to do is create pattern, a rectangular pattern. And you can do different types of things with the rectangular pattern. So we're going to select a face here. We got this face, this face. I have to roll this around so I can click the faces here. That face and that face. And the extent we want to do spacing, and we can do 3 or 4. We can say the distance, let's just call it 6 millimeter, for instance. And quantity, so we want to do symmetric. Symmetric. I think I want, let's see here. I'm doing something wrong. Oh, select directions. So the direction is going to be this way. So now I want to pick the distance. Let's put 6 in there. See, now you can see what it's doing. And I don't want 6. I want maybe 4. Yeah, that looks better. And then I can do the number of them. And then if I do symmetric here, see how it puts 1 on each side? Then I can just sit here and increase the quantity. 1 there, there. And hit OK. Let it give it a second to think because my computer isn't super powerful. But look at there. We got all our water inlets through the part. Just that fast we've drawn a part. Pretty slick. Now the last thing I want to do is I want to put an edge, a rounded edge on this thing because I want to make a soft edge. So we can pick fillet here, and we can pick that line around there, and we can type in, let's call it 2 millimeter. And look at that, puts an instant soft edge on it. Hit OK, and we're done. Isn't that slick? Now that wasn't that hard to do, was it? Now that's why I said it's important to have all the drawings, the important dimensions in front of you, because I have this sketched out and I've drawn this up 1 or 2 times now, and I'm not perfect at it, but we've got a part here. The cool part is now I want to save. I want to file and I want to do a save. Now right now you can pick folders. You can create a new folder if you want. Um, we can call it a new project here. We can call it a training video. I can spell training video uh, part 1. Let's just call it that. Hit save. And so now we have training video part 1. We're going to select that folder. And then we're going to, so see that pop up here? And then we're going to water intake. And hit save. Now we've saved that. That's saved off in the cloud, ready to rock and roll. So what I want to do now is I want to get this ready to print on my 3D printer. So I'm going to come over here and I need to export this file. And there's probably better ways than this to do it. This is what I've been doing lately. And if I learn better ways, I will update you folks on better ways. So we're going to export this to an STL file and hit export. And you're going to see the status come up here. It's going to take a while. And I'll fast forward through that so you guys don't have to sit here and wait for my slow computer to process this. Okay, now that the file is complete, we can go ahead and close this. We can minimize this. And we're going to go ahead and open up Cura. All right, there's Cura. Now I'm going to pick my CR10 V3. There we go. I'm going to use a standard quality. Then I'm going to go File, Open File. And depending on where you've got your stuff going, I've got it automatically depositing into my downloads. And there it is. There you see it. You can roll this around however you want. You can see that it's laying flat. That's what I want. That's what I like. And I've got all my settings here as to what I like. Then I can hit slice. And it's going to slice it. Tell me it's going to take 2 hours and 19 minutes. Then I can hit save to file. And it's going to save it in a folder that I have designated as my 3D objects folder. So we're going to go ahead and save that one there as a new design. We'll call it and hit save. Now that's all you got to do. That's saved off. We can minimize that. And over here, I'm opening up my Octoprint. As you can see, I've already got it printing in the background here. And this is all it's telling me what my Raspberry Pi temperature is, my tool temperature, my bed temperature, all that funny stuff. And so here, if I want to upload, that's my brand new one right there. I double click it, it's uploading, and when it's time to print, I can hit print on there. But anyway, you can see that it's already printing. So that was pretty simple. That's start to finish. When this is all done, I'll show you what it looks like. And that'll be the end of this video. I hope that was helpful so far. Alrighty, you just finished up printing. Look at that little beauty. A couple little stringies across that hole, but this hole came out real clean. I'll put a brim on here. I like putting a brim on some things. It just gives it a little more bed adhesion, and it peels off really easy. There we go. Beautiful looking part. Let me show you the screw that goes in it. That's the type of screw that's going down in there. It sits down in there like we want. Not too bad. That's how it comes out the other side. Let me show you what it looks like with two of them put together. That's what it looks like put together. They're mirror images of one another. This locating feature that we drew is right there, so these go on in one direction. And on this particular design, it wouldn't have to go together in one direction. The other design had a curvature to it, but I have a feeling this is going to let enough water come in for the water pump not to starve. But I will test and tune to make sure that doesn't happen. Because I've seen some of these outboards that have just like 3 little holes, and that's all the places the water can get in on the lower unit. So I have a feeling this will be more than adequate. Anyway, that'll keep the debris and the trash out of the water pump. Pretty sleek. I like it. It turned out well. All right, there you have it. Old and busted, new hotness. Just that simple, guys. Hope that was fun and informative and helpful for you folks. This is what you can do with Fusion 360 and a 3D printer. So it's pretty cool stuff when you can design your own stuff and build it, build replacement parts. Pretty slick. Now this is PLA. It's going to be a testing ground to make sure this works and functions. Yes, this won't have the longevity for outdoor use as far as UV resistance. But for me, my boats all park inside, and the only time this thing would see the most of the sunlight would be when it's trailering to and from the lake. So anyway, this will be a good test. Eventually I'm going to get some ABS and some ASA to print well for me, and then I'll have some long-lasting parts. Hope you guys enjoy this. Get out there, try something new, have some fun with it. This is Michael, and I'm out.